Inheritance. One of the major advantages of object-oriented programming. C++ inheritance allows us to bundle similar objects. We need to write less code and can be more efficient. Today we'll look at what inheritance is and how to use it. We will focus on the basics that are easy to learn and apply. Hi, my name is Zen and welcome to my channel. So what we're going to do today is to create several different classes and to show how we can use the benefits of the inheritance for our advantage, to write less code and to reuse the code that we already have. So for that I have already created the main, and this main now is completely empty, just including some output and including one of definition of shape. Shape itself is also already completely empty, so there's nothing really inside, but we will be filling this one right now. So what we want to do is to create two different classes that are fairly similar but not identical. And this is where the power of inheritance will directly show. So the goal is to create a class which resembles a triangle and to create a class which resembles a quad. So for the first thing that we need to do for that is to implement an additional class, which is a point, because a point will be then just reused by triangle and quad. But anyways, let's get started. So the first thing that we need to create is a class for point, because point is then the basis for everything. Point itself is fairly straightforward, so we will get a constructor where we get an x and we get a y, because we are in Cartesian coordinates, so a point just have an x and a y, and because this one should be public accessible, we make it public, and it will have a member which is x, and it will have a member which is y. So this looks already quite good. We still need to define this constructor. So what we're going to do, we will go to the CPP file. We will include the shape.h file, and then we will implement the functions. So the constructor of this one, constructor in this case is float x, float y. And what this constructor shall be doing, we're using here an initializer list, should just apply x to x and y to y. And basically that's already it. We still need to add these empty curly braces, because this is where the code would go, but there is basically no code. So at this point we already have now created the class point, which we can then reuse in our definition of a triangle and in our definition of a quad. So the second thing that we want to do is create a class triangle. And the class triangle will have now 3 points to be constructed. So we give in 3 points and we will construct a triangle out of that. So we again declare everything public just for simplicity, and we will create a constructor which will take a point A, which will take a point B, and which will take a point C. So just to be, let's say, accurate at this point, because point, we know now that it's a fairly small class, so it just has 2 data members, but we don't know that one for sure. So to be aligned with best practice, we should make these one as const references. More on that probably in a later video, but for today just accept that those should just be const references. For, let's say, scale and efficiency, probably not important today, but definitely important later on. If you write code that scales or that should scale, then this is a definite thing. One additional thing that we want to do to give our triangle an ID. So at this point we just use here unsigned integer for that, and we call it ID. The data members are also quite straightforward. So we do have the point A, we do have the point B, we do have the point C, and we have an ID. ID is something that usually objects will have at some point. So the ID is very, very common. If you want to refer to a particular object, it's really useful if they have unique IDs. And this ID is not necessarily unique at this point, but yeah, you get the idea to access something via its ID. So the triangle itself, the declaration seems good. So we need to step onto definition. So we will be going here into our shape.cpp, where we will implement then the constructor. The constructor, as I pointed out, is just constructing, and it's not really doing anything else. So we can just copy that one, copy the second one as well, C, and the last one is just the ID. And what it will do is also the same as for the point. It will here take A and assign it to A, take B and assign it to B, and take C and assign it to C, take the ID and assign it to the ID. In the end, we will need the curly braces, but inside the curly braces, nothing inside. As we see here, it's still complaining about the uint16t. I don't know why it's not complaining here, but we're just missing a header. This is the standard int.h header, so we will include that one. And then also everything here should afterwards be fine, and it recognizes the type. So this one, standard int h, just includes the various types, and also the fixed size types, because here with this integer, I know that no matter on what platform this one runs, it will always have 16 byte or 16-bit, so 2 bytes, which is a great thing to have for portability and so on. So I always use these fixed size types. So the triangle is not really capable of doing a lot right now. So we will enter 2 additional methods, and we will make the data members private. So because I say no one should be able to access point A, B, C, and ID, we can just make them private, and everything should be all right. And it's an implementation detail that nobody else other than triangle needs to know about. So we will implement an additional method, which we call GetID. So it will return the ID. And in this case, it really does make sense to have ID private, even though we're now adding something that can return the ID, but we're just interested in getting the ID and not in having the user to set it. So he can access it and read it out, but he cannot modify the value. So here for triangle, we now need to implement this method. It's triangle, in this case, GetID. And what this one is doing, I think it's quite straightforward. It will return ID, and it will return as type the same one that ID actually does have. So I GetID at this point is ready, and the last thing that we want to do is GetArea. This is where it gets a little bit more complicated, but I think it should not be too complicated. So GetArea will just return the area of the triangle. So because we want to reuse it, we will define and GetArea, which returns the size of the area for 3 arbitrary points, and can reuse that one later on. So we will define this outside the class. We'll define method GetArea that just gets point A, a point B, and a point C. This one. We also need to now define how this one looks like. So we go inside our shape.cpp file and implement the GetArea function. So I will just copy this one to be a little bit faster. and then we can implement the GetArea function. It should return though a float value. So at this point we want to return a float value, GetArea. Now he should stop complaining, everything should be all right. And we need to calculate the area based on the 3 points. So I have this formula looked up and we will just speed through it. Okay, now that we have implemented the GetArea function, we can move on to actually implement the triangle GetArea function. So this one doesn't need anything else than the information the triangle has, but we still need to implement it though. So in our case, we will say the triangle function GetArea needs to be implemented, and this one will return GetArea, so the general function that takes 3 points with A, B, and C. Because this function will also return a value, we assign a float to it, and should be done at this point because it returns a float. If we look here now at the function, it will complain that it needs additional values or that this function doesn't exist, because it will look up the GetArea function in the namespace where it's currently at, and this just retrieves the GetArea function with 0 parameters. So we want it to look in any namespace, and that's why we need to add the 2 colons at the beginning. Then it will look everywhere and it will find this function that it has the 3 parameters with the points defined. So at this point we should be fine. We do have now a triangle defined, and the triangle has an ID and an area, and everything should be properly defined, and we can now go to our main program. We will create here 3 different points. So we will create point A with, let's say, 0, 0. Then we will create point B with 1, 0. And we will create point C with 0, 1. And then we can create a triangle out of that, which we call triangle. And this one just gets A, B, C, and the ID 0. So we just also create here the ID. And put it inside. And now what we can do is output the area of the function. So my triangle's area is, and here we just call the function triangle.getArea and end this one with a line ending. So let's try to compile this and see what happens. I already have prepared here the console, and now what we need to do is compile our program, which we do by clang++, main.cpp and shape.cpp, and we name our output program. So let's wait, and apparently it did work. Program did show up, and we can run it by using program, and my triangle's area is 0.5. Given the points, it somehow does make sense, right? So the second class that we want to create is now a quad. A quad is fairly similar to a triangle, but not exactly the same. But we still need to implement it. So we will take triangle, and being the good programmer and knowing nothing about inheritance, we will just copy it and rename everything. So we will have then a quad. Quad in this case does not need 3 points, it needs probably 4 points. Sorry. Also has an ID and also has an area. It has 1 more point as a member. And the implementation also looks a little bit different than that one of triangle. So we go here to the implementation side, and we basically need to re-implement all the functions here. So in this case, we need to add here another point, which is point D. And for point D, we will just add it here as well. And because it's not a triangle, but it's a quad, we name the functions appropriately and just replace everything that is necessary. So we will have here now an ID, which basically looks completely the same, and an area. The area we can just reuse part where we know that area of a quad is basically 2 times the area of a triangle, given that the 2 triangles always share 2 sides. So if we go in the right order, then always B and D should be on opposing sides of the triangle. So we say here we use the triangle ABD, and then we additionally add to that B, D, and C, and should also be fine for our quad. Quad definition looks all right. We do have the area, we do have the ID, and we can go back to our main file and additionally create a quad. So we create an additional point D, which is then in 1, 1, 1. And then we create our quad. So the quad will use the points A, B, C, D, and in this case the same ID. And then we will also add the output. So in this case, my quads area is quad GetArea, and we should already be ready to compile this. It somehow does work, and we are able to run the program and see the quad has twice the size of the triangle, which is also what we would expect. So now where's the point with all this inheritance? Inheritance is bundling similar objects together. And I wanted to show that here we already have re-implemented now some stuff that looks very similar between triangle and quad. They both are basically the same thing, or they have at least some common properties which we want to exploit. And this is something that you need to look out in programming. If you have classes and objects which share different or share the same thing, then you should be able to extract an inheritance hierarchy for that. So we try to do this now for the triangle and the quad. So we implement the class, which we call shape, and the shape class will now combine the things that the triangle and the quad have in common. So we see, for instance, that both of the classes have the GetID and GetArea function. So we say the shape should also have the GetID and the GetArea. We also will create something, or create the constructor. This is just something that we need to do. And we also see that in the members, they share the points, but we don't want to recreate those, but they definitely also share the ID. So we will additionally put here the ID. And then what we need to do is derive triangle and quad from exactly this base class. In order to do that, we will add the double colon and add shape at the end. And here we do exactly the same thing and add shape at the end. So we now say that triangle is a shape and quad is a shape. So this, every time you hear somebody talk about is a, this usually means inheritance. So a triangle is a shape and quad also is a shape. And now we can get rid of a lot of the definitions in the triangle and in the quad, because the GetArea and the GetID is completely the same. So the GetID function, we can get rid of this one completely. And what we need to do to get rid of this one is to implement it in shape. So we go into our C++, and here we just say we implement GetID for shape, and also put it here at the top because we define shape first and it's just best practice to have it in the same order. And here for the quad, we also can get rid of the GetID function. So the main benefit is we have now written less code. So we have just written this function exactly once, and we have reused it at several places. The reuse also is an important part, because if you now fix a bug in this function, then the bug is automatically fixed in all of the places where the function is used, which is a great thing to have, believe me. The additional thing that we can get rid of is GetArea. However, GetArea is a little bit different than GetID, because GetID was just retrieving the same ID that both of those classes anyway had. So the implementation looked exactly the same for both of the classes. But what we want to do with GetArea is we want to have two different implementations still for triangle and for quad, but we want them to share the same interface. So what we're gonna do is declare the GetArea function virtual. In order to do that, we add the virtual specifier at the beginning, and this tells the compiler that each derived class might implement a different function for GetArea. One thing that we additionally can do is to specify something called a pure virtual function, which is this equals 0. A pure virtual function means that if somebody derives from shape, and this is so if he inherits from shape, he has to implement this function. Otherwise, it won't compile, which is a good thing if you have a function which doesn't really make sense in a general class, because GetArea for a shape, it doesn't really make sense. You can't retrieve or calculate anything because you don't know what kind of shape it is. But for the other classes, it really does make sense. In order to now see that this is a virtual function, one thing that we need to do in the derived classes to add the override specifier. Override will be placed at the end of the function definition, and it will just tell you that this class has overwritten the GetArea function and has its own implementation. So this own implementation override is great. We have declared it purely virtual, so no need to define this function as well. What we still need to do is to do the correct inheritance of the constructors. Because the ID is now moved to shape, what we need to do is to implement the constructor for that. So we implement now a shape which has an ID. And we also need to get rid here of the ID, of the implementation of ID. It will still have the ID, but it will pass it to the base class. And we will see in 1 second how this one goes. So shape does now have an ID, and we implement the constructor for that first. So in this case, we implement here shape, the constructor for shape, which takes now an unsigned int as ID, and this one initializes ID with ID and does nothing else. Here we already see that now the compiler is already, or IntelliSense is already complaining about this ID because it doesn't exist anymore in triangle. However, what does exist is the base class, and we can just pass ID here to the base class, which takes an ID. And we do the same here, and then we should already be done. So if we now go through the call hierarchy to understand things a little bit better, here we pass A, B, C and ID to the triangle. The triangle is a shape, so in the call of the constructor of the triangle, A, B and C, they will be passed to the members of triangle, and the ID will be passed to the constructor of the underlying base class, which is shape, and the constructor of shape will then assign it to ID, and at this point the class is fully constructed. One thing that we should do for let's say just completeness is we should add an destructor which is virtual. So no need to do it in this particular tutorial, but it's just best practice that whenever you have a base class, you should have virtual destructor of your class. And we can just declare this one as default because it should do exactly the same behavior. The only thing is that it should be virtual. All of the other classes will automatically inherit this virtual destructor, so everything will be all right. Why you need to do it is a little bit of a longer story. I won't explain right now, but just get in a practice whenever you have a virtual function somewhere defined, you should add a virtual destructor for this class as well. So let's jump to the compiler and compile a program, which we do by the same command as previously. And now we see that the program is doing basically exactly the same thing, but in a different way. So we have reduced the complexity of triangle and quad by introducing a base class shape. We have used the double colon operator to inherit from this base class and have included some of the logic into the base class. The logic which is completely shared, which has the same implementation for all of the derived classes, can be completely normal, so no need for virtual or anything, and is just in the base class. The methods which are differing between two of the classes, for instance this GetArea function, this one can be declared virtual, and by virtual you indicate to the compiler that each of the derived classes will have a different implementation of GetArea. That's all for today, so turn on your machine and get started. Tell me what you want to hear about next, and as always, enjoy coding.